What's up, everyone? Welcome back. Patrick here. Moving on to the next question, still dealing with transformations of quadratics, the vertex form of a quadratic. So what we got to do in this case is we have to take each of these sets of transformations and then find the corresponding equation after these transformations are done on that base function y equals x squared. So we've gone through a couple of videos like this already where transformations are given in words and then we have to create the equation. But sometimes the wording can be in different kinds of formats. Sometimes you could be given like the vertex and then other transformation scenarios. In this case, notice that we're not given the vertex at all, but we're given enough words in order to find that a, h, and k value. So just as a quick review, what we're doing is we're taking the y equals x squared and then we're converting it to that vertex form, a bracket x minus h squared plus k. So really all we have to find for both of these scenarios is the a value, the h value, and then the k value, and then we can get the equation. So let's go through these one by one. So there's a vertical stretch by 2. So vertical stretch by 2 means the a value is going to be 2. So we are done with that right there. What I like to do is do this. So I like to go through each sentence or each set of transformation and then put that value here and then cross it out and then just keep reading. And then sometimes there could be like multiple sentences that correspond to the same letter. So a lot of times the a value, they'll say there's like a vertical stretch or compression, then there will also be a reflection, then that would cause the a value to be negative. In this case, there is no reflection, so the a value is going to be positive. So the next one, translated 3 units right. That means the h value is positive 3. And then the remaining one, translated 1 unit up, means the k value is positive 1. So we've gone through all the transformations. That's the a, h, and k, and then we just have to plug it in there. So we'll have y equals 2x minus 3 squared plus 1. That ends up being the final equation for part A. Same thing with part B. Let's find the a, h, and k value. So let's go through these one by one. Vertical compression by 1 over 3. The a value is 1 over 3. Reflected in the x-axis means that the a value is negative, right? So it's negative 1 over 3. And then translated 1 unit left means the h value is negative 1. And there's no mention of a translation up or down, so the k value is going to be 0. So plugging these into that format, we end up with negative 1 over 3 x plus 1 squared. And there's like a plus 0 here, but we don't have to write that 0. Now be careful with the h value, right? Opposite signs, because it's x minus h. So we got positive 3, negative 3. We got negative 1, positive 1. Because this negative 1, it's like x minus h, which is negative 1, like that. So the two negatives turn into a positive over here. All right, so those are the two equations for those two sets of transformations.